this point, you're 100% working solo and silent. Are we clear?
Yes, ma'am.
Alright. So because this is the new lesson that we're doing today, I have Alejandro videotaping us. Everyone turn Alejandro. So we might be in your face a little bit as you ride. I think that's okay. So go ahead and write your name on your paper, and once you have your name written down, go ahead and put your pencil down. So team, make sure your hands are not on your face, that you're not slouched down, because this is my last whole class warning. Thanks for being there. Hey, give me random videotape, you know me, but alright, so today, we already read our objective. In this unit, we are doing a deeper dive into analyzing triangles. In our last unit, we looked at trig functions and right triangles. This unit will be looking more in depth at triangles. And we're going to apply properties of a line. What we did in our do now was look at two properties, which are distance. This is how we analyze a line. And we also looked at our midpoint formula. What I want you to do is take 30 seconds, turn and talk to your neighbor. What are some other properties of lines that we can calculate? What are some other properties of lines that we can calculate? Go. What do we know about slope? We have slope. What else do we know? Yeah, but 10 more seconds. We're coming back together in 3, 2, 1. Hear my voice, clap once. Hear my voice, clap twice. Alright, so we said distance, what we did in our do now. We have midpoint, which we looked at in our do now as well. What else do we calculate when we're talking about lines? Dynasties. Everyone's tracking dynasties. What's a formula for slope? You said, I think. You guys are teaming up.
Y2 minus Y1 over X2 minus X1.
So what's our slope formula, Dylan?
Y2 minus Y1 over X2 minus X1.
Now what do we know about slopes? What do we know about slopes that relate to lines? So I have 2 people so far. What do we know about slopes and they relate to lines? I think Bryce has his hand.
No, I'm just stretching.
So only 2 people know. Like, we have a slope. What a slope tells us about a line. As you start talking, maybe we got some memory. It shows the steepness of a line. What happens if we have 2 lines? How does our slope tell us about a relationship between 2 lines? So go ahead and turn to your neighbor. How does the slope tell us? What does the slope tell us about the relationship between 2 lines? We don't know. They're parallel to something. Alright, so my voice clap once. Then my voice clap twice. Alright, so what do we know? We have 2 lines. How are their slopes related to one another? Shakira.
If they're parallel and
Alright, we could build off that. Gaps. What do we know about slopes if they're parallel? What do we know about the, okay, we know the lines never meet. What do we know about their slopes? Thanks.
The slope of parallel lines will be different.
She said our slopes are different. Do we agree or disagree, y'all? We have parallel lines. What are the slopes? I'm answering.
Both are the same.
The slopes are the same. What about intersecting lines? Are those slopes the same or different? These are slopes are different. And what set of intersecting lines do we really look at in algebra, especially? What kind of lines? Do we just look at any two intersecting lines, or we look at any perpendicular lines? And what do we know about the slopes of perpendicular lines? Maria, what do we know about the slopes of perpendicular lines?
They're opposite.
They're opposite. That's half of it. Jonathan,
Yeah.
what are the slopes of perpendicular lines? Does anybody remember the slopes of perpendicular lines? I know this is a lot of algebra. So how many of y'all are taking the math test next week? How many of y'all are taking your math test next week? So everyone's hand should be up. It's a rhetorical question. How many of you keep your hands in the air if you plan on taking the ACT? Yeah, your ACT is, I want to say, 35% geometry, including trig. The rest of it's algebra. The rest of it is stuff like this. Go ahead. It creates a 90-degree angle. But our slopes are what we call opposite reciprocals, where you flip the sign, you flip the fraction, and you change the sign. I'm not back here. All right, so today, in today's lesson, these are some of the properties you're going to be using when we're talking about next. And you're not only going to continue to use these properties in geometry, but like I said earlier, you're going to use these properties when you're talking about your ACT. The ACT, as you, I think you probably are talking about with Ms. Frazier, like those different points can be the difference between tens and thousands of dollars in scholarships. Our goal is to get everyone at a 23, so that way you get into some competitive schools like Texas A&M, UT Austin. But the lower your ACT scores are, it limits your options for the colleges you pick. In addition to limiting your options for college, it also limits your options for scholarship. So when we're talking about a review of these concepts, yeah, this is algebra, but this is going to help you get the most bang when you're talking about your ACT, and especially when you're talking about your math scores. Okay? All right, so let's dive into today's Explore lesson. So Explore lesson is very different from our Discovery challenges. In our Discovery challenges, we work as teams and groups and ask questions and come back together. In today's Explore plan, you will be working solo, silently, and independent. In the second semester, as we try to get closer to our goal of 100% of us reaching mastery on our common assessment, I have to look at your individual data. A lot of us, seem to lean too heavily on our team, and so right now I need to figure out when I'm doing tutorials and when we're doing individual push-ins, like where are the gaps that I need to fill. And in order to do that, I have to know how you work individually. So in this paper that you have in front of you, make sure that you put as much information and show your thinking, similar to what we did yesterday with my model problems. Like the model problems had a lot of me like making notes, it was neat and organized, you could follow my steps because you had to rewrite it. So that also prepped us for today. So one of the things that I realized in the first period is you don't have a lot of space to write on that paper. So everyone right now, take 10 seconds and take out a sheet of paper.
It's about to die.
Well, I just wanted to frame it. So just give me about 5 more minutes, and I'll tell you when to stop.
All right.
So we're coming back together in 10, 9, 8, 7, 6. Make sure your name's at the top of your new paper you have out. So on your blank sheet of paper, what I need you to do is make sure that your thought process is lined out and is legible. I have the dot cam map because we're going to be looking at each other's work. I know we have a pretty good culture in this class, but one of the things that I want us to do, some of you will be looking at how did she come up with this, similar to what we did yesterday, where you looked at my model problem and talked to one another about my thought process. anticipated, like remembering formulas. We have our formulas on the board, plus you were able to kind of like activate that with our do now. The formulas are also written on your discovery challenge. So before we get started, our pencils are still down. And let's go ahead and read through the paper. So, Gerardo, start us off. Number 1.
Above the vertices A 0, 8, B 6 0, and O 0 0 to construct rectangle area.
Beautiful. Janelle, number 2.
Find the midpoint C of A and then follow.
Yeah, so there's a spot for you to write your coordinates. And then on your paper is going to be your space to where you actually write down the work that you did. Okay. And then part B for number 2, Del say. Yeah, so we had find the midpoint of C. That second statement says.
Find the midpoint of B and O B and they need not a that.
Beautiful. And then you also have a space for your midpoints of B. Go ahead, Gabs. What are we doing for number 3?
Connect C and D, create mid-segment.
So, Jonathan, we can hear you, and it's a distraction.
I'm sorry.
Can you read it one more time?
Connect C and D, create mid-segment CDM.
Beautiful. Alice?
Use slope and distance formulas to complete the table below.
All right, so you're going to complete that table, but where are you going to show your work, class? On your substitute paper. Beautiful. Number 5, Dynasty.
Using the slope of segment AB and segment CD, what is the relationship between these segments?
Or what do you notice about the relationship? And what I want you to do on this one is using what you're learning in in English about the meal. We're going to be pushing each other to write using academic language and writing in complete sentences. Yesterday I gave you a sampling of how to write a math academic sentence in the model problem. All right, number 6.
What do you notice about the relationship A, B, and C, D?
And 7.
What can you infer about the relationship between the mid segment and the third side of the triangle?
And so on number 7, you're going to come up with your own inference, and then we're going to do an inference together as a class. Does that sound good? All right, so you'll have 10 minutes. You'll be working solo, silent, and independent. I will be walking around. And if you have questions, raise your hand. All right, your time stops now.